Hello friends, welcome to PG department of LJ University. This is a lecture series of subject Applied Mathematics for first semester student in Computer Engineering branch. Here I, Dharmin Patel, discuss the topic Conditional Probability from the unit number 5, Probability Part 1. Now, already in the last lecture, we studied about the probability and its properties. Already we studied the conditional probability at a school level, and now we cover the concept of conditional probability in more variables. Let us start our topic with one example. Here in a school, there are some transportation services available. There are 5 buses available to transport the children, and each bus generally takes the same time, and shouldn't take any bus to reach at its home. But finally, bus number 3 is a very long route bus, so it takes more time to reach student at home. That means if student choose the third number bus to reach at home, so he will be late at home. And in other buses, student can reach at home early. Here we want to know that what is the probability of student will reach late at home. So if student choose the third number bus, then it's a possibility that student will reach late at home. So now we have to calculate what is the probability of student will reach late at home. Here we have a total 5 number buses and 1 bus is late. So there are 5 total buses available and 1 bus have a long route. So our probability of student late at home is 1 by 5. It is approximately 20%. But when some rainy days are in the rainy season, students' attendance is low, and for bus number 4 and 5 are cancelled. So in this case, now we have to find the same probability due to this condition. So when the rains comes and 2 buses are cancelled, then what is the probability of student will reach late at home in the rainy days when 2 buses are cancelled? So finally, in this case, there are 3 buses are available and 1 bus have a long route, so student will reach late at home due to 2 buses are cancelled. So its probability is now 1 by 3, because now we have a total 3 buses available and 1 bus is late, so it's a 33% possibility. So now our possibility of student coming late at home will be 33%. In the normal days it will be a 20%, but now it will be increased due to some conditions. So what is our condition here? Bus number 4 and 5 are cancelled. They are regular buses. So finally, in this case, student probability of student will reach late at home in the rainy days is 1 by 3, approximately 33%. So that is in the normal day it will be a 20%, but in the rainy day it will be increased. So that type of probability is known as conditional probability. Now we will see the definition of the conditional probability. Here, a conditional probability is defined as the likelihood or an event or outcomes occurring based on occurrence of previous event is called the conditional probability. Now we will see another example. 10 cards numbered in the one box and they are mixed properly. It's known that number on the drawn on card is more than 3, then what is the probability if number selected is even number? So here actually 10 cards are mixed in one box and they are numbered with the 1, 2, 3 up to 10, and if we pick up the one card from that box and we know that this number is greater than 3, then finally what is the probability of occurring even number? So if we know our selected card number is greater than 3, in that case we have to find the probability of even number occurs. So here our sample space is 1 to 10 and number of S is 10, and B is number on the card is greater than 3. So we have a possibility are 4 to 10. So there are total 7 numbers in B. So probability of particular B event is 7 by 10, and A is our favorable event or likelihood event, which is even number on the card. So our number of elements are 2, 4, 6, 8, 10. So 5. So our probability is 5 by 10, that is 1 by 2. Now what is A/B event? So if B is done, that means we know our card number is greater than 3. In this case, our possibility is 4, 6, 8, 10, and A occurs. That means the even number greater than 3 are this. So finally probability of A/B is 4 by 10, which is actually wrong. So why it is wrong? So here we understand by the one concept. So here our sample space is S and it takes the 1 to 10 number, but it is divided into two parts. So our first event is B. We know that our card number is greater than 3. So finally A is even number event. So number are in B is 4, 6, 8 and 10, which are common from A and B because each number is greater than 3 as well as each number is even. So they are common number for A event and B event, and 5 and 7 are only in B because they are greater than 3 and they are odd. Now A contains the 2 number because only 2 is remaining even number and it is less than 3, so it is not in B but it is in A, and 1 and 3 are outside both the set. So finally this is our situation, and now we have to calculate the probability when B is occurred. If we know that our number on the card is greater than 3, in this case what is the probability of even number? So in the here possibility of 2 is not occurred because we know that our number on the card is greater than 3. 1 and 3 are also not possible. So only we concentrate on B. Here this set is A intersection B. So A intersection B covers the 4, 6, 8 and 10 elements, and now we will find the probability of A intersection B is 4 by 10. It is the probability of A intersection B with respect to whole sample space S 1 to 10. Now we want to find the probability of B, A/B, and in this case we only concentrate on B set because we know that our number is greater than 3, so we are taking the sample space as a B, and this is our sample space. And now we calculate the probability of A intersection B according to the sample space B, which is 4 by 7 because 1, 2 and 3 are not in B. So finally this is our probability of A/B, and we will calculate by this formula also. So probability of A slash B is also known as probability of A intersection B upon probability of B. So that is actually 4 by 7. So that is the concept of probability, conditional probability, and in this case, if some conditions we put on the here in this case, if we put some condition on particular favorable event, here if we put some condition in terms of if this is the conditional probability concept. Now here if we put some condition on our likelihood events, and that is called the conditional probability. Now we will see the one more example. A die thrown 3 times and event A and B defined as A is 4 on third through and 6 on the first and 5 on the second row. Find the probability of A given that B is occurred. That means B is already occurred event, and then find the probability of A. So here A is this event. We throw the dice 3 times and 4 number place at the 4 number time. So here this is event A, 4 on the third time. So here we can see that all the elements have a last component is 4 because A event denotes the 4 on the third time, and B is 5, 6 on the first time and 5 in the second time, and 1, 2, 3 are up to 6 are at the third place. So finally these are the elements of B. The number of B and number of A are very large and number of B are 6. So finally this element is common for both the events because 6, 5, 4 is also present in the event A. So finally number of B is 6 and A intersection B is only one element, 6, 5 and 4, and the total number of elements in the sample space S is, when we roll the dice 3 times with 6 cube, that is 216. Probability of B is 6 by 216, and probability of A intersection B is 1 by 216. Now probability of A slash B is B occurred first and then A occurs. So finally its probability will be A intersection B upon probability of B, that means 1 by 6. That is our probability of conditional probability when of A when B is occurred. Now properties of conditional probability are like this. A, E and F are events of sample space S. Then S slash F is nothing but probability of F slash F, that is 1. And second property is if A and B are any two events, then we can say that probability of A union B slash F equal to probability of A slash F plus probability of B slash F minus probability of A intersection B slash F, and last one is probability of A dash B equal to 1 minus probability of A slash B. So that is some properties of conditional probability. Now we will see the concept of total probability theorem. Here E1, E2, En are events of some sample space S, and they are actually disjoint events. That means we participate our whole sample space in n parts such that each event E1, E2, En are greater than 0. That means all the events are non-empty. Second condition is E1, Ei and Ej are intersection of that is null set. That means each events are disjoint, and E1 union E2 up to En, union of all these events is equal to S. So that is called a partition of our sample space. So in this case, A be any other event. So finally probability of A is calculated like this. So that is a product rule for conditional probability. Now we will understand this theorem by particular example. Here S is our sample space, and these are our partitions E1, E2, En, and A is another event, and in this case A is intersect to every partition. Here 2 dice thrown via random experiment. Ei is the number on the first die, which is 1 to 6, and A be a event, all the elements are equal. So finally, in this case, we will understand the concept. Here, these are our partitions. E1 represent the first number on the die is 1. So these are the elements. In the E2, first number on the first die is 2. In the E3, first number on first die is 3. Similarly, in E6, we have a first number on first die is 6. So this is number of S is 36, and A is event. All the numbers are equal on the both dice. That means number of A is 6. Now each partition cover the same numbers 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6 in the sample space, and number of E1, E2, En all are equal, that is 6. So this is the our situation. So finally intersection of A and B is nothing but probability of A equal to 6 by 36, that is 1 by 6. Probability of E is E1, E2, En all are also 1 by 36 because each covers the equal number of elements. So then it is 1 by 6, and finally we calculate our probability by this formula. Here we have a probability of A intersection Ei for each element, and now probability of A slash Ei is like probability of A intersection Ei upon probability of A intersection Ei. So that is 1 by 6, and summation of that is equal to these elements. So finally this is our probability of A, which already we know that 1 by 6. So that is the concept of total probability theorem. And now in the next lecture we will discuss the posterior probability or Bayes theorem. Thank you very much.